I'm Jenny from the IEEE Xtreme Organizing Committee of University of Jaffna. I warmly welcome all of you to the Prolog to Xtreme 15.0 session this evening. As we know, we are ready to face one of the largest programming competitions in the world. To prepare you to face the competition, we are here with the keynote speakers, Mr. Budvin Edippuliarachchi and Mr. Sunera Avinash. Mr. Budvin Edippuliarachchi is a final year computer science undergraduate student from University of Moratuwa. He was a well-performed student in Royal College Colombo, and also he completed his internship as a software engineer of the Mitra Innovation. He is a person with a lot of experience in IEEE Xtreme competition as a member of Team Codebreakers, one of the most talented teams which placed Ireland ranked 3rd and selected for the top 100 teams at the world ranking at last year IEEE Xtreme 14.0 competition. Mr. Sunera Avinash is a software engineering undergraduate student from University of Moratuwa. He was a well-performed student in Kaluthara Vidyalaya, and also he completed his internship as the software engineer of the WSO2. Currently, he is working as a software engineer in IXD Labs. He is a person with a lot of experience in IEEE Xtreme competition as a member of Team Codebreakers, which placed Ireland ranked 3rd and selected for the top 100 teams at the world ranking at last year IEEE Xtreme 14.0 competition. They are here to give us some tips and tricks. Without taking much time, I invite respectfully Mr. Budvin to take over the session.
Okay, so thank you for the introduction. I hope I am audible and I hope you can see me as well. So good evening, everyone, and we'll start the session on Prolog to Xtreme 15.0. So let me share my screen. I hope everyone can see the screen, right?
Yes, we can see this.
Okay, so we'll start the session officially. So we are from the Team Codebreakers, as our host mentioned previously. So I'm with here today with Sunera, Avinash, and we have another member, Deepan Ishtavira, who happens to be the founder of the Codebreakers. So unfortunately, today he'll not be joining with us because he's some other work. So anyway, we'll start and continue our session. So first of all, we look at what is IEEE Xtreme. I think most of you know what is IEEE Xtreme. Anyway, I'll give a small introduction. So it's basically a competitive programming competition. So you all know what is a competitive programming competition is. Where even given a small timeline, you are given with what do you call those tasks, puzzles, and programming algorithm related questions. So you have to come up with solutions, not only the solution, but it's best solutions, what we call some optimal solutions, right? So the special thing about IEEE Xtreme is it's a 24-hour long competition. So that means usually it starts at around 6 in the morning. So it goes for 6 in the morning in the next day. So it's a 24-hour competition. Usually it starts on Saturday. I'm not exactly sure about this time. So for these competitions, there are like in all the years there are thousands of teams. That means 3,000 plus participants, because like for each team there are 3 people. And it's also well recognized competition. Like there are also other competitions like Google Summer of Code, the Google Hash Code. Along with them, IEEE Xtreme is also a competition in that level. So if you happen to be participate or get a good rank in the global arena, everyone will recognize that rank. That means if you have a good rank, they know that you are capable of doing something special. And also in all the years from Sri Lanka also, we have a few teams in the global top 100. So in last time, I think there were 4 or 5 teams in the global top 100 from Sri Lanka. And I think a few years back, I'm not sure exactly in which year, the champions of the IEEE Xtreme was from our university. So it was quite few years ago. So anyway, the current situation is this. So what are the benefits of like participating in IEEE Xtreme? So we'll give you some like 5 things, but there are many more things. So as I used previously mentioned, it's a well-recognized competition. So everyone knows. So if you get a good rank in the competition, everyone knows what are you capable of, and it is also a good qualification. I say, like in interviews in big tech companies, like in these companies anyway, when you these interviews where you are given these multiple extreme type questions and you are required to answer those things during the interview. So when you, if you have a good rank in these competitions, they already know that you are capable of such things. And also you as a third one, you are presented with some points like gifts if you happen to be in the first 100 in the global ranks, and if you are in the top 10, you are given it some more valuable stuff. So this might not seem like very expensive stuff or anything. Like I would say, like we can consider them as some collectibles or something. So if you look here, we have a t-shirt and a water bottle, some kind of things. So you can't get these things from the shops or anything. So yeah, kind of collectible things we get only from the competition. So it's kind of a pleasure to have those stuff. And also the long-lasting memory. So these are a photo of 3 of us. So not only for IEEE Xtreme, so with this team we participated in many competitions in many universities, and I think we came for competition in your university as well. So they are quite nice memories. And also our team is like we are not only together for the competitions, we continued our work, and like we managed to create a startup with this team, and with some others also. So you will get a good set of friends by like participating in this kind of team competitive games. So yeah, let's move on. So these are the type of questions you will get in IEEE Xtreme. So maybe here I think we have both the people like who are participating for the first time and also who have participated 1 or 2 times. So anyway, so for the people who are participating for the first time, these are the type of the are given in the competition. So there are questions from normal mathematics and geometry, and then there are like very theory related applications. That means theories that are very much related to competitive programming and algorithm. That means graph theory, game theory, and number theory kind of things. And then there are questions like this special kind of a thing we call divide and conquer. That means it usually involves this dynamic programming 3D type of algorithms. And also there are like interactive type question. That means you are not straight away giving an answer from the code. You should play with the computer to get some inputs, like they are giving an input, then you are giving an output, some kind of a thing. So you have to make your code like that. Those are called the interactive type questions. And also there are questions like puzzles. That means they are not associated with any theory or anything. Like you have to be creative, and maybe sometimes searching the internet also, like some puzzle kind of things. Then you will get some idea on how to answer that question. So So moving on. So this is another important point in this computer programming questions. In like maybe 50% of the questions, maybe more than 50%, we can straight away think of a solution. That means this is how we solve this problem. The hard part is we have to make that thing efficient. In most of the cases, the first what you call solution we think of is not that efficient. You can get to the solution, but it is not that efficient. So it's we have to like improve our solution always to get the required complexity they expect from our solution. So you have to have some idea about the time complexity. Someone is trying to talk. Okay, so I'll continue. So you need to have some idea about what the time complexity is. So we'll see. I think if you have taken any course related to data structures or algorithms, you have learned about this thing. Anyway, I'll give a short introduction on what time complexity is. So let's take an example. So let's assume you are given a sorted array. That means sorted means all the elements are in either ascending or descending order. So then you are given a key or an element to check where that element is in the array. So you are given a sorted array, and then you should find a given element in the array. So if that is not in the array, you should return -1. So it is, if that is in the array, you should return the index of that element. So the left hand side, I have given the most intuitive or the most naive approach we can code here. So we can do this in a linear search. So we have an array and we have to find the element. So we can loop through the array from first element to the last element. If the current element is equal to the given key, we will return the index. Or if we happen to finish this loop without returning, we should return -1. I think it is straightforward. So we can say the time complexity or the worst case time complexity of this algorithm is ON. That means worst case. That means we are assuming that we have to run this loop up to the end. That means there can be instances where our key is at the start of the array, at the middle of the array, or the end of the array, or our key will not be in the array. So the worst case thing happens when our key is not in the array. So that means our loop should go from 1 to n. That means the length of the array. So that is the worst time complexity. So that is order of n. So we can optimize this slightly because I previously mentioned that this array is already sorted. So you can do something like a binary search. So I have given the visual representation. I think visual thing is more easy to describe. So let's say this is our sorted array. We have to, let's say, search for 76. So what this binary search is all about is reducing our search space by a factor of 2 always. So initially our search space is the whole array. So in the first step, what we do is we go to the middle element of the array and check whether it is the key we are looking for. In this case, that means 76. So if it is the keys we are looking for, that means if 76 was in the middle of the original array, we'll just return it. So if middle element is not the key we are looking for, we compare it against this value. If our key is less than this value, we will reduce our search space to the left hand section of the array. if our key is greater than this value, we will reduce our search space to the right hand section of the array. I think it does make sense, right? Because if our key is less than this one, it should not be in this part, right? Because we already know that this is a sorted array. So with that reasoning, we go to the right part of the array since 76 is greater than 47. So likewise, now we do that procedure for this part also. We will compare 76 with 77. So 76 is less than 77. And go to this part and finally find 77. So if we couldn't find in the last case, that means when we are our search space is one element, if our key is not equal to the element in the array, we'll return -1. So the basic idea of binary search is this. So in this algorithm, the worst case time complexity we say as order of log n. That means we have to do this procedure maximum of log n number of times, where the n is the length of the array. In the previous algorithm, we had to go from 1 to n, but in this binary search thing, we have to go from, let's say, 1 to log n. We have at most the log n number of steps, then we will, or we will not find the given key. So we managed to reduce our time complexity from order of n to order of log n. So let's say for 10 elements, let's say we need 1 second to do a linear search. For 10 elements, if that need 1 second, for 100 elements, we can assume that it will need 10 seconds. That means because the function grows with the order of n. But when we use binary search, even if we say we multiplied our array size by 10 times, but our running time will not get multiplied by 10 times. It will only get multiplied by the log of our multiplier. So that's kind of the optimization we achieved from the binary search. So in the code, you can see that this is a recursive approach. That means we are defining the function, and also depending on the cases that I have described, we are calling again our original function as a recursive approach. So this is the recursive solution for binary search. I think this is clear. So can we do better? So we have done some optimization. So let's see whether we can do better. So this is kind of another way to do that. It's the same binary search. Like logically, it's the same as the previous one, but I have removed the recursive stuff, and I have went with the iterative approach. That means the same logic applies here. That means we are reducing our search space, but we are doing in a way that it is no longer recursive, but it's now a iterative approach. So start and the end are the start and end of the search space, our current search space. So in the start is the first element, end is the last index of the last element, or the length of the array. So while this condition maintains, we can reduce our search space. So this is same as the previous algorithm. This also has the worst case time complexity of order of log n. And so what is the benefit of this approach? So since we are not not using a recursive approach, we can avoid stack overflow error. That means you might not know that there's a limit where we can call our recursive function. So we can eliminate that kind of a pitfall by using this kind of iterative array. So this is kind of very basic example. So these are kind of things we do in those competitive programming questions. We always try to, let's say, in the start we'll come up with some not so efficient solution, but as the time goes on, we try to optimize it further by removing these recursion with loops, substituting with loops kind of thing. So it's all about finding the optimal way to solve problems. I think we are clear on that. So if you have any questions, I think we can uh, do those in the Q&A session. So please keep your questions for now. We'll answer that all in the Q&A session. So yeah, it's about finding the optimal way to solve problems. So then I'll briefly go through some data structures. Like I'll cover some of the basic things and some of the advanced things, and I'll give some reference to more advanced things. So all those people with more experience can refer to them before going into the competition, or maybe even refer to them during the competition also. We also do that. So speaking of data structures, you probably already know some data structures, right? Even if you are a total beginner, you know what are simple. The most simple one is a variable, right? Then we have arrays. That means you can say as a continuous allocation of several variables. Then we have stacks, queues. Stack. I think you should know this. It's last in first out queue. That means stack provide operation as pop and push. So you push means you insert an element, pop means you are getting an element. So this behaves as a last in first out array, and the counterpart of that is the queue. That means first in first out array. So the methods in a queue are enqueue and dequeue. So you are enqueuing from one end and dequeuing from the other end. So it's a first in first out procedure. So linked list is kind of similar to array, but in a linked list you can't say directly access an element. You have to traverse through the linked list. Since to go to, let's say, go to the fifth element, you have to go from 0, 1, 2, 3, 4 and 5. So that's the difference between array and a linked list. So in competitions, you don't get to implement this. That means you don't have to build a stack to solve problems. You can just import, probably in the language you use, there are already this implementation coded in that language, these arrays, stacks, queues, and also linked lists. So you have to know what these are capable of and in what scenarios we should use them. So these are some of the basic stuff. So next we'll go to some of the not so common ones. So one important data structure is a hash table, or in some languages this is called a dictionary. So this is a key value pairs too. That means this is not an array. You can store key value pairs in a hash table, or some context it's hash map or something. So anyway, so this is kind of illustration of a hash table. So in a hash table, there is an internal hash function. That hash function is used to hash the value of the key we provide. So what happens is, let's say we want to add these two entries, banana 1 and apple 2. Banana 1 means this is a key value pair. The key is the string banana. The value is 1. Here the key is apple and the value is 2. What happens when we insert that to a hash table is we hash the key and get the hash value. So for banana, the hash value is 100. This in 100 also, we then convert it to an index of an array. Actually, the underlying data structure of an array is a no, underlying data structure of a hash table is actually an array. The hash table is designed such that we can access any element in the array with a constant time. So we hash the element, then we convert that to an index, probably with some modular function here, and then we go to that particular entry, and then we store our key value pair. So that's the basic idea of the hash table. So theoretically, all the insertion, search, and deletion should happen in constant time. That means you have to search for the entry with the key banana. What you have to do is you have to hash the element and get the index and go to that particular location. So you have near constant lookup time for hash table. So these things are already been done in this many of the languages and sometimes you use. So you just have to import that required data structure to use. So there are some issues such as handling collisions kind of thing. So they are already being handled by those libraries. So if you think that your solution needs this kind of a key value pair store, you can use a hash table. And also it's not much suitable for iterating. That means you can't be relying on the ordering of the underlying array. So that can be uh, changed from time to time. So that's the use of a hash table. So yeah, we move forward. Another more common thing in this computer programming question is the graph data structure. So it is used to represent different kind of thing. In most of the things, this is used to represent road networks, and also you can represent dependencies. That means in this graph, let's say D is dependent on A, can be modeled like this, and C is dependent on A, and A is dependent on B. That kind of a representation. And also we use graph to represent flow networks. Also, it means you can consider these numbers in the edges as the capacity of that particular, so something like that. So there are different use cases. The graphs also, there should be a way to represent it with our existing data structures, right? So we, even if we draw the graph like this, we cannot code that easily like this image. So we will use, we can use two different notations to store the graph. First one is the matrix notation. The second one is the list representation. So what this does is, so the matrix representation, so let's say there's an edge from D to A with weight equal 4. So you store that here from D to A, weight is equal 4. So that is the matrix representation. So when that is converted to list representation, you just you only store what is required things. That means these from D there's only one outgoing edge, that is to A with weight equal 4. So this is the list representation. I think we are clear on that. So where we use a list representation is when our graph is not that much polluted with edges. That means theoretically we have here we have 4 nodes. That means theoretically we have 16 edges, but here we have only I think 7 or 8 edges. So there are only half of the edges. So it is better to use a list representation because that saves the memory. Because in matrix representation you can see that half of the entries are empty. So that is the difference between two representations. You can choose either depending on the situation. And another one is the tree. Tree is kind of similar to a graph, but in a tree there are no cycles. In the previous one we had one cycle, I don't remember. So anyway, in a tree data structure similar to a graph, but there shouldn't be any cycles. And if the tree is balanced tree, all the operations happen in log n time. That means this tree is not so balanced. That means, so in this part is balanced 18, 17 and 20. So by, if we only choose these 3 nodes, it is a balanced tree. But let's say here in the 6 we have 2, 3, 4 as a balanced thing, but this 739 is not balanced. So if 13 and 9 was in this kind of a triangle situation, we could say that this is a balanced tree. But if the tree is balanced, most all the operations run in a login time. That means inserting, searching, and deleting. So most common variant is the binary search tree. This is binary search tree, and more advanced one can be I could say like B trees, ABL trees, and there are things like red black trees. So the special thing about these advanced things is like they can self-balance them. That means once we start to insert nodes into the tree, there's an internal operation which automatically runs so that the tree is self-balanced. So that's the story about trees. So most of the cases you will get to use binary search trees. So if you feel that your tree would be unbalanced in a significant way, you can use these more advanced self-balancing trees. So that's about the trees. And this one is heap. That this is not so much common data structure. We also like tend to forget there is this kind of data structure when solving problems. Because it's not heavily used, but we can use this in a very smart ways to solve problems. Heap is kind of looks like a tree, but the properties depending on whether it's min heap or a max heap. In min heap, the topmost element is the minimum value. In the max heap, topmost element is the maximum value. So that's the only property it has to follow. So there are several operations. Heapify means we are building the heap, inserting, deleting, and extracting min max. That means extracting the topmost element. So this is commonly used as a parity queue. That means in a normal queue we know that it's a first in first out manner in normal queue, but in a parity queue that means for each element we have priority. So we insert element as the same as a normal queue, but when we are removing elements we get the value with the highest priority. So in this case, if we use a heap, that means the topmost element. So that's the story about a heap. So keep in mind that there's a data structure called heap. This can be used as a priority queue. It will come in handy when you implement several algorithms. So yeah, those are pretty much about the data structures I was hoping to cover. I'll give some references at the end, so you can refer to more advanced stuff about data structures. And let's move on to some of the algorithms you will commonly encounter in these competitive programming environments. So the most basic procedure algorithm is sorting. I think you all have heard about many of those things, bubble sort, merge sort, quick sort. So I'm not going to explain how these sorting algorithms work. So anyway, you don't have to implement these sorting algorithms in the competition also. You just have to use one of the sorting algorithm to just sort your arrays or something. So in many of the occasions, your language or the runtime environment will provide you a sorting algorithm. Some of the not so common ones I have mentioned here is like they might not be readily available. That means these counting sort, predict sort, or topological sort. So you might have to code those things if you want to use them. So talking about counting and predict sort, so the counting sort is mainly used with integers, and also we should know that the integers are in this particular range. That means let's say we have 50 integers, we know that they are between 1 and 100. So in that case you can use a counting sort to sort these stuff, those elements. So it has a time complexity which is better than other sorting algorithm because there are only integers and we also know the range. And Redux sort is implemented by comparing the significant digits of each element. So its complexity depends on the number of elements and the length of the largest number we have. That means the number of digits in the largest key we have. And topological sort means it's not a number sorting algorithm, but it is used to kind of sort the nodes we encounter in a graph. That means I earlier mentioned that graphs can be used to model dependencies. That means here 1 is dependent on 6 and 5 is also dependent on 6, kind of thing. So topological sort is used to sort these nodes according to those dependencies. That means the person with no dependencies should come at the first place. So the node we put in the second place should not have dependencies with nodes after that. So that's the reasoning behind it. That means you can see that after we topologically sort this graph, all those directed edges only go in the right direction. So there cannot be any arrow going from right to left. That's the main idea of topological sorting. So probably this is implemented with some algorithm, probably with depth first search. So we'll come to what depth first search means. So keep in mind that there's a thing called topological sort. You can use that to order those according to those dependencies in a graph. And moving on to another paradigm of algorithm, that means which is the divide and conquer. So this is kind of one of the oldest tricks we can use to solve problems. So when we are presented with a problem, where we can check whether it can be solved with this paradigm. That means we can check whether we can divide our problem into smaller subproblems and solve those subproblems. And if we know optimal solutions for those smaller subproblems, then we can check whether we can combine them and go to the optimal solution of our original problem. So that's the main idea of divide and conquer paradigm. So it is kind of the basic concepts for things like greedy algorithms and dynamic programming algorithms. So I'll give a small example for divide and conquer. So quicksort is one of the algorithms which use this paradigm. So how this quicksort works is like in a divide and conquer algorithm, there are actually 3 steps: dividing, conquering, and combining. So in this quicksort thing, the dividing part is we will find a pivot in the array. So normally the pivot is taken as the first element or the last element. There are also algorithms implementation where they randomly choose an element as the pivot. So anyway, let's say we got the first element as the pivot. So in the dividing phase, what we do is take the pivot as a middle element, and all the elements less than the pivot, we move those stuff to the left side of the pivot, and all the elements which are greater than the pivot, we will move them to the right hand side of the pivot. So first step is the dividing part is now over. We have the pivot in the middle and all the small elements are in the left hand side, large elements are in the right hand side. So if we can now recursively sort these arrays, our job is done, right? Because we know that these things are already less than the pivot. So if we can sort these 3 recursively, we can. So what we do is we will do the same procedure for these smaller arrays, and we will come up with the solutions for those smaller arrays. Now we can just combine those two small arrays with the middle element as it is, or the pivot, and we will end up with the sorted array. So that's one of to divide your problem so that the optimal problem, optimal solution for those sub problems will result in a global optimum way. So that's example of divide and conquer paradigm. So one of the other types which use divide and conquer is a greedy algorithm. So greedy algorithms are algorithms which they take series of decisions when running the algorithm. So the decision to the choice to a particular decision is taken so that it seems best at the moment. That means that algorithm does not like look ahead whether this will be efficient when I complete the algorithm. So in greedy algorithm, it just makes a choice that seems best at the moment, hoping that it will result in a final best solution. So greedy algorithms are, because of this nature, it is relatively efficient. But on the other hand, sometimes they may not be the optimal solution. So I have given here a small example. This is the example for the first one, coin problem. That means let's say we have different types of coins. So we have let's say these are in rupees 1, 2, 5, 10, 20, 50, 100, and 500. So these are the different types of coins we have, and let's assume that we have a unlimited supply of each coin. So what you have to do is we are given with a value, in this case 93. We have to come up with a combination of coins that adds up to 93 with the least number of coins. Means the sum of the coins we choose should add up to 93, and also our solution should use the least number of coins. So in this greedy pattern, what we can do is we will start by selecting the largest coin we can choose at the moment. That is the greedy choice we do. So for 93, the largest coin we can get is 50. 100 we cannot get, 100 is greater than 93, so we can get 50. So after getting 50, we are left with forming this 43. So for the 43, largest we can get is 20. So now we are left with 23. 23, the largest we can get is, we can get another 20. So likewise, we can finish this as. So in this case, this is the optimal solution. Coin with 15 and 2 coins with 20 and 2 and 1. But to work this coin should have some sort of property. So I'll give references to check these underlying theories. So these coins are not adhering to that property, this greedy choice will not always work. So for example, in the second scenario, we have coins as 1, 5, 6, and 9. Our initial value is 11. So if we move with our greedy choice algorithm, we will take 9. That's the largest thing we can take. Then we are left with 2. That means we can only get 2 ones. That means 9, 1, 1. So, but this is not the optimal solution in this case, because you can form 11 with 5 and 6. That means only 2 coins, right? So that's the trade-off of the greedy algorithm. They run in a relatively efficient way, but sometimes they may not provide you with the optimal solution. So your problem should adhere with those greedy properties. That's the sense of greedy algorithm. So there are 2 more examples, you can look into them. Fractional knapsack problem and some problems related to tasks and deadlines. So in these tasks and deadline things, usually for greedy algorithms, what we do is we sort the task according to the deadline of the task. Then we try to use a greedy choice. So that's the all about greedy algorithms. So next one special thing is dynamic programming algorithm. So this is kind of an improvement over the greedy algorithm. That means we are combining the efficiency of greedy algorithms along with the look ahead kind of a thing. We make these choices when we are sure that our choice will surely lead us into a global optimal solution. So to do dynamic programming, there should be two properties, optimal substructure and overlapping subproblem. So I'll shortly describe these two things. And there are two ways to implement, top down and bottom up. It doesn't really matter how you which implementation you use, but if we are using recursion, you should know that the thing I mentioned earlier about those recursion errors because of stack overflow things. So maybe it's sometimes better to use a bottom-up approach. So anyway, so let's look at small example on dynamic programming. So this is kind of a intermediate to advanced concept. So the people who are very new to competitive programming may not understand it straight away, but it's a good tool to have in your possession in this question, because in with dynamic programming you can code algorithms very efficiently. So one of the example is this rod cutting problem. That means you are given with a rod. So let's say with length 4 in this case, and you want to cut the rod so that you are selling each piece to a predetermined price. You have to maximize the amount of money you get. So let's say our rod has a length of 4. So if we do not cut it at all, we can get a price of 9. That means we sell it as it is, we can get a price of 9. So if we cut it in this place, that means one size of 1 and 3. So 1 has a price of 1 and 3 has a price of 8. So in this situation also the money we get is 9. But in this situation, if you cut in the middle, there are equal size with size 2. So the 2 has a price of 5. So in this scenario, we get total money we get is 10. So I think this is the most optimal way in this situation. Yeah, this is 9, 4, this 3 are 7. So 10 is the maximum we can get. So when the rod is too small, we can try out all the possibilities and come up with the best solution. But when this number gets very large, this particular approach gets exponentially complex. That means you will need a very high running time to complete this algorithm. So you can do a dynamic programming approach. So here I will not go into explain all the stuff since we have not much time remaining also. I'll anyway provide you with these slides, so you can refer to these slides and understand the procedure, so you can reuse this knowledge to other dynamic programming approaches. So the basic thing is you are recursively applying the algorithm to smaller and smaller part of the rod, and also you try to memorize some result. That means when we do this recursion, you tend to encounter same problem again and again, same subproblem again and again. So in such scenario, you can only calculate the answer to a particular subproblem only one time, and you can reuse them. So that's the essence of dynamic programming. So you can refer to these slides. I'll share the slides with you as well. So you can understand why this approach works and what is the running time of this approach. Yeah, so these are some basic stuff about graph algorithms. There are several ways to traverse a graph. So the most common two things are depth first search and breadth first search. Depth first search means you are going deep when you're starting. That means starting from one to go from down. Then you go in the next section. That's how depth search means. That means you are going into the depth at first. But in breadth first search, you are completing one layer at a time. 1, 2, 3, 4. Then go to 5, 6, 7, 8. In the earlier approach, the pattern is into downward. But in a breadth first search, you are completing each layer. So depending on the situation, you can choose either of these algorithm for graph search. And also there are several algorithms for calculating the shortest paths in graphs. So the very famous one is this Dijkstra algorithm. So it is kind of very commonly used algorithm, but it has an assumption that there are no any negative edges. If there are negative edges, it will give you a kind of a suboptimal solution with some wrong values. So this is also a greedy algorithm. So you can simply find the implementation details of the algorithm. So you just have to know when to use the algorithm and when not to use these algorithms. So let's say if you have negative edges, you should use Bellman-Ford algorithm to find the shortest path from a given node to other nodes. So it is slower than Dijkstra, but you have to use that if you have negative edges. So that's the simple explanation of shortest path algorithms. And these are most some kind of advanced stuff. I'll not describe those things here. So people who needs those advanced things, that means who have some experience on the things I previously mentioned, you can always refer to these things, because like many of these things come in handy when IEEE Xtreme or in many of the local competitions. These primes, factors, and greatest common device finding algorithms, and modular arithmetic is also a very helpful thing. In under that, there's a thing called modular inverse. So please look into that when you are doing modular arithmetic, because in as I can remember, in all the years in IEEE Xtreme, we got a question related to this modular inverse. So look into those things. I will give you some references where you can refer to those things. And the right hand side, we have some theories related to game theory. NIM game is kind of a very abstract small game related to game theory, but there are problems with these questions related to NIM game. And Grande theorem is also a theorem which explains about this NIM game kind of things. And this game of life is kind of a computer simulation game or something, but we have come up with competitions where they are directly giving a question related to game of life. So this is also kind of a thing you have to look out for when talking about number theory and game theory. Yeah, so these are some more algorithms, and I'll share the slide with you anyway, so you can look into these as well. Yeah, so I'll give a brief introduction on how to approach IEEE Xtreme problem. So this is kind of a general guideline, but a very strict one. This is how we did in our competitions. So first of all, you have to read the problem well and understand what they are actually asking for. That means there can be many descriptions, many all those stuff, unnecessary details in a program. So you have to filter out what they are actually asking for. So then you can start coding by taking the inputs. That means in this problem, you should take an input. So when you are coding to get those input, you will get more insights of the problem. That means you will get to know you have to take these inputs. That means I have to use this input in such a way. So then, as I previously mentioned, come up with some algorithm. First of all, what you do is like to come up with an algorithm mentally. So, or you can use a pen and paper, use an algorithm, or write things, write diagrams or anything. Then write your program, test your program locally, and then submit. So depending on the efficiency and the complexity of your submission, you will get marks. So if that didn't get the 100% mark, you just have to try again. So that's the only thing about competitive programming. You are trying again and again to until you find the most optimal solution. So this is kind of a question format in the IEEE Xtreme we get. So normally IEEE Xtreme is held on CS Academy platform. So this is the format of one question. So in the left hand side, you will get the description of the question and the input output constraint and solution to some of the test cases. They provide at least one or two things. And the right hand side, you have the code editor to code your solution. Well, you can use any language. In most of the things, this language selection does not matter, because like you can see that there's a time limit and a memory limit. So when you change the language, this time limit and memory limit is changed according to the language. So they do not expect you to always code in C, C++ or Java or anything. They expect you to code the correct algorithm. So you will get time according to the language or the runtime you use. I think we can give you some small hands-on session also. Sunera, can we do some small?
Yeah.
Yeah, okay. So I'll transfer to you to do some screen sharing. And he will, I think he'll do the question I previously mentioned.
Yeah. Can you see the screen?
Yes, yes, we can see.
Okay. Okay. Yeah. As Budvin mentioned, yeah, I'll be like doing the problem that he showed. This is a very simple question actually. But I'll be doing this to like show you how a normal problem in IEEE Xtreme goes. So normally I'll say like take 2-3 minutes to read this, but since we are like running out of time, I'll explain this straight away. So the problem is like this. You are at the bottom of the stairs, you want to go to the top, and you can take 1 step or 2 steps at a time. So they are asking how many ways to climb the stairs. So in this example, if there are like 3 steps, you can go either like this or like this or this. So there are like 3 ways you can climb the stair. So they are giving you an input saying, okay, this is the number of steps you have to climb. So what are the number of ways you can climb the staircase? I'll actually describe this more with the image, like picture, like drawing. So if there is like, if there is like a staircase like this and you are at the bottom, you have to go to the top. You can either go like this or go like this or like this. So there are like 3 ways to climb the staircase if there were 3 steps you need to climb. Right? So how you can like come up with a solution to this? Like there are like many ways you can think of a solution. As I said, this is a very easy problem as well. So I really urge you to try out these problems. Actually, these problems are, I'll actually put the link in the chat as well. This is the link. I'll urge you to later try out these problems. Actually, there are like many old IEEE Xtreme questions in the site as well, so you can try them out before you go into the actual competition. So how to solve this? In most of the cases, like in most of these kind of problems, I'll say that first you need to think of the base case and go upwards. So in this case, think of the most basic case. The most basic case you can get is 1 step. You are at the bottom of the staircase, you need to go to the top, and what are the ways you can climb the staircase? So in this case, like it's very clear that you can only go in like this way, like there is only one way to climb the staircase. Now think of the next case. which is the two staircase one. So you at the bottom, you need to go to the top, so you can go like this or like this. So there are like two ways. After you have like drawn some pictures or something or like this and understood the problem, let's try to come up with the problem that you can like code, like you can easily develop a program. So I'd say like in the next step. So in the next step one, there are three stairs. You at the bottom, you need to go to the top. And thinking about this, you can understand that in the first step you take is either this taking one step or taking two steps at a time. If you take one step, you end up in this position, and now you have two steps to climb. And you have previously found out that there are two ways to climb the staircase if there are two steps. So if I go to here, I will have two steps to climb, which means I have two ways to climb the staircase. And if your first step was two step one, you will end up in here, and now you have one step to climb, and you know there is only one way to climb the staircase if there's only one step. So if you end up in here, you have one way to climb the staircase, and in total, you can either first take this step and go in two ways, or go to this step and go in one way, which means in total you have three ways to climb the staircase. And thinking again, like for the four step case, where at the bottom, you need to go to the top. You can either go here or here. If you go here, there are three steps to climb, which means there are three ways to climb the staircase. If you go here, you have two steps to climb, which means two ways to go up. So there are five ways. Now, I hope that you can like see the pattern in this. So if I go to the next step, which means there are five steps, you can either go here or here. If you go here, there are four steps, which means five ways to climb. If you go here, there are three ways to climb. So in total, there are eight. If you are like, I think by now, like you must have understood like the solution is always the sum of the previous two answers. Like if there are n number of steps, you just need to find the ways to climb in -1 and in -2, and the sum of these two ways is the answer for them. So if you are like familiar with Fibonacci sequence or something, like you'll understand straight away that the problem basically reduces to find the nth Fibonacci number in this kind of sequence. So all IEEE Xtreme problems, I say like 95% of them are like this. They are like giving a kind of a big description and setting up some kind of problem, but underneath they are like a very small kind of in most of the cases they are small kind of problems that you can easily solve by using maybe seemingly unrelated computer science thing. So in this case, what you have to do is actually develop a program to find the nth Fibonacci number. So likewise, once you have reduced the problem to doing such a thing, now you can easily code it. Since we are running out of time, I'll also like quickly code it as well and show you how normally our workflow goes. First, as Budvin says, what we first do is actually take the inputs. And in this case, there are many things that we do to like saving time. For example, if you, I hope you can have to see, there are like we have written some snippets as well. So for things that we always code, like things we have to always do in such competitions, we usually save those things as snippets. So like depending on your ID, you can like save them. And those things actually do help in a in most of the cases to save time. For example, prime number finding things or binary search, those kind of things. I just say if you have coded them previously, save them somewhere and you can reuse them. You don't have to develop everything from scratch in the competition. Like you can always reuse stuff. So yeah, then I'll take the n, which is this one, and for now I'll just print a number. And also another thing we do is take those sample cases and put them into a file. For example, here I have an input file. I put them those input into this file and feed them directly into the Python program like this. So we can like test the code we write easily. Or you can always like run the program and type them yourself, but in most of the cases you will find typing the input in a file and feeding it directly saves you time as well. So now let's write a function to take the number and print it. Yeah. Okay. So how we can develop the solution for this problem? Like I said, this is the Fibonacci sequence. So if you look online, you can easily find answers as well, which is totally okay. Like you don't have to come up with everything. If there is a resource online that you can use, always do, because others do as well, and it is not forbidden or anything. But yeah, in practice questions, I say mostly try to do them yourself, because those actually help to build your knowledge. So in this one, you have to come up with the Fibonacci sequence. So in the order like this, 1, 2, 3, the next one is 5, next one was 8, like that. And what you can do is basically you can develop this recursively. I think many of you might be already familiar with Fibonacci sequence actually, because it's a very famous problem in computer science. So you can always code it recursively or use an iterative approach. And as Budvin said, always, if you can think of the iterative approach, always go for that. Especially if you are using a language like Python, because those kind of language have some restrictions on recursive algorithms. And if you are using something like C, C++, it doesn't matter most of the time, because the compiler does some optimizations. But in things like Python, always try to develop a iterative, like a loop-based algorithm, instead of like writing a recursive one. So if you write a loop-based one for this one, what you can do is simply define two variables, and in each iteration you stitch them up. Like A will get the value of B in the next iteration, B will get the value of A plus B. So basically this one will be A first, this one will be B first, and in the next iteration this one will be A and this one will be B. So this one will be equal to A plus B. The sum of this one. So you just have to code it. So basically like this. I'm going for n minus 1 iterations, because there are two variables and that is the number of iterations you should go to get the correct answer. But you can always like code it first and try it out, and you will understand you have to put n minus 1 here. Yeah. So first I'll have two variables with 1 and 2. Then as I said, I'll switch them up. This. And in the end, I'll return A. This is it actually. But you have to handle the base cases. So if A equals 1, you return 1. Sorry, not A. N equals 1, you return 1. If n equals 2, return 2. Actually, this is it for the algorithm part. Now we can like test it. It says 8. Let's check. I think for the 5, right? Yeah, the answer is 8. So it should be correct. You can also like test with other inputs as well. For example, I can put 1 and 3 as well. It says 3. Let's check. Yeah, and this one should give 1 3. Yeah, 1 2. Yeah. So the answer seems to be correct. So we can what is the problem and try to optimize it. But always like first come up with, it's fine to come up with a dumb solution. I feel like if you get some, like getting some points is always more important than like getting nothing. So if you can come up with at least some kind of solution, always do so. And if you can optimize it later, you can always do, because there is not much of a penalty for retrying. There is a small penalty, but it doesn't matter at the long run. So what you can do is submit again and again and try. Yeah, I think that's it for the hands-on session.
Yeah,
Budvin,
you
right?
can.
Yeah,
I'll
yeah.
continue the presentation. Yeah. So yes, small stuff remaining in the presentation. I'll try to finish within minutes. Okay, so these, I hope you can share my screen. Yeah, so these are kind of rules of thumb when it comes to choosing your algorithm. That means you can get some idea by looking at the input constraint. That means you just saw that in the problem description in the bottom side. They give the constraint to the variables they give as the input. So by looking at them, you can get some idea of what sort of an algorithm you have to code in the solution. So if the input size is very small, that means less than 50, 20, 100 or something, the time like expected time complexity will be probably very high. That means for small inputs, you cannot run those n squared time complexity kind of things. So the time complexity might be probably very high. That means all those 2 to the power of n kind of all those things. So that means probably it is trying all the permutations or all the subjects kind of a thing. So likewise, you can get some idea. So let's say if the input size is in the order of 10 to the power 5, it's probably the time complexity of the answer is n log n. That means it may involve sorting. That means most of the sorting algorithms use n log n time, or any other data structure that takes log n time to access, maybe a binary tree or the heap kind of a heap data structure kind of thing. So if the input is very large, that means more than 10 to the power 7 or 10 to the power 10, 10 to the power 15 kind of thing, it is highly likely that it is a log n approach or a constant time. That means with such large input, you cannot run one loop even. You will run out of resources, that means time and memory. So probably it is a log n approach. That means log n probably involves in binary search kind of thing, or probably a constant time. That means you are directly feeding that input to an equation. You can get the solution by one equation. So these are kind of rules of thumb when it comes to looking at the input size and algorithm, kind of a guessed approach. So as final tips, if you are stuck at a solution, as Sunera mentioned, at least try the most intuitive approach you can think. So in the earlier hands-on session, he mentioned that the most intuitive approach we tend to do when uh, computing Fibonacci numbers is that recursive approach. So always try to, if you cannot think any other way, just try it and get some marks. So you will realize that, okay, my solution runs out of time and memory in some of the cases. So then I look in how to optimize the solution. So always if you have at least one solution, just try it, then try to optimize it. And also Sunera mentioned about this thing, code snippets. I think VS Code has a good support for snippet. I'm not exactly sure about the other IDs. Maybe in PyCharm or IntelliJ or any other thing, there might be code snippets. So you can define this code snippet beforehand going to the competition. These actually saves a lot of time. So here we have provided only an example to get some inputs. That means get a list of inputs and directly map it to an array. So you don't have to limit to inputs. That means some algorithms like Sunera mentioned, binary search or DFS or Dijkstra algorithm. These are like very common things, right? So you will, in many questions, you will get to use this algorithm. So you can define very large snippets, or you can input them with a few characters. So that will saves a lot of time, and also that will save prevent you making errors. That means when you are defining a snippet, you can carefully define a snippet so that there are no errors. But when actually coding in the competition, you might encounter some errors, and because there is no time or panicking, you will end up even small error. That means instead of a plus mark, you will end up using a minus mark. That means the final input is wrong. So it will also prevent you from doing such errors. And also this one also we previously mentioned, the language does not matter. That means most of the time, according to the language, they adjust your time limit and the memory limit. In some very extreme cases, there might be instances if that is beneficial to use C++ kind of a solution, but those are very rare. They tend to make sure that any language can be used to do a particular algorithm. So as final helpful things, since this time I think maybe in previous time also, most of you will compete this IEEE Xtreme remotely. That means in most of the teams, they might not be in the same house or the same place or something. So in such a scenario, you can use these kind of tools to actively collaborate things. So the first things are ID. Anyway, you have to use an ID whether you do it in one place. So VS Code is one thing. There are a lot of other things. And this REPL.it is online IDE, and also you can use it to share your codes, and it also provided execution environments for Python, C, C++, Java. So let's say you have to code an algorithm in C or C++. Let's say your personal computer does not have it installed. You can quickly use REPL.it to quickly code the algorithm and run it in that itself. So that's an online ID with an execution environment. And CodeShare is, so as the name suggests, it's a platform to share your code. So you can multiple people can log into a code editor and they can share the code things. And you have to anyway get a meeting to participate in these things and discuss build up solutions. So we are currently in a Zoom session. You can always use Zoom, Google Meet, or there's a thing called Jitsi. It's also a completely free solution. You can try that as well. I mentioned that because Zoom has always this 40-minute time limit, and I think Google Meet also now enforces 1 hour time limit unless you have this G Suite Pass or university affiliated Gmail account or something. So that's it of those online tools. And also to collaboratively sketch solution. That means when we are working together in same place, we always use pen and paper to sketch some algorithm diagram, so we can make sure that everyone is on the same page when discussing a particular solution. So you can use these things to sketch things collaboratively and share those ideas. And finally, this is also a thing that I think the organizers requested us to briefly mention about the points and the weights of the each question. So when the competition is going on, this is the format of the tasks you can see. That means I have got a screenshot. So here we have 5 questions. So this is the name of each question. And in this column, you can see your score. That means if you get 100% correct, this circle will fill up to 100%. That means, as Sunera mentioned, sometimes if your algorithm is not that great, you will end up getting only a portion of the mark. So this is the percentage that shows how well you did in that particular question. So this column is quite interesting. It says points word. When a new question appears, it starts with 100 points. That means if you do that perfectly, you will get 100 points. But when people continue to do that question, that means the more and more people are able to solve that question, the worthiness of that question goes down. That means, so here we can see, I think many people have done this coupon code question. Now it's only worth 87.8 points. So even if we did perfectly, we only get, everyone gets 87.8 points. So as compared to this restaurant reopening question, only few people have tried, or few people have solved the question. So it has still has a high points worth question. So it's almost half 100, only few decimal points behind. And you can see by looking at this column which questions are much easy. That means if points works has significantly gone down, that means many of the teams are solved it. That means it's most probably a well-known algorithm that is directly available in somewhere. So look out for those things when you are doing in the competition. So it's about question format, those things. And finally, so it's kind of late for this advice, but I think have the competition in 1 or 2 days. Anyway, you can still refer to these resources, online competitions and related books. So here we have the first book is Introduction to Algorithms. So this is kind of the reference book that all the courses, all the universities use to teach basics to advanced algorithms. So this is the kind of the reference book with all the theories and stuff. This second book is more aligned with all this competitive programming question. That means it has all the algorithms for very common type of questions. I think Sunera will give you a link to that book also. Yeah, he has put a link to the competitive programmers handbook. So it is a free book you can access. So there you can find many stuff related to this competitive programming solution. You can always refer to other books and also this online contests as well. So that brings us to the end of the presentation. Yeah, we have mentioned some of the achievements we have done. So this is from your university, UOJ Coders. Also, we participated in several competitions. In some of the competitions, we were champion. In some of the things, we were not able to sometimes get to the top 3 as well. So that is the thing. So in every day you won't win, but if you try harder and harder, someday you will get a better rank. So that's, I think we have today for presentation. So we use like excessive 28 minutes or so. So I tried very hard to formulate the presentation so that it suits all the beginners and also advanced people. Anyway, so this comes to the end of the presentation. So if you have any questions, we can answer now. I'm not sure whether we can attend, want to attend to any other things since 30 minutes have passed the allocated time. So anyway, we'll hang in there for 2 minutes. If you have any questions, we can answer.
Hello, am I audible?
Yes.
Yeah. in a topological sorting manner, if we are going to using the Python program, there are some several inbuilt utilities, right? So if we are going to use in the problem solving, what could be the time complexity? So we are using the inbuilt functions, right? So if we are using that inbuilt stuff, would it take too much of time to run in the environment, or some anything errors will pop up?
I think inbuilt solution always they are implemented so that they run in a very optimal way. So if there is something available inbuilt, you can always use those stuff. And the downside of that thing is, so if you want to use topological sort in a slightly customized way, I don't know whether they provide those customizations. So if you want to directly only use that algorithm, if that is available in the default runtime, I'd say go for it. Like it doesn't do any harm. So, and check whether you are not importing any third-party libraries or anything, because all these platforms only have those required standard libraries. So if you have a implementation for that, you can always try that. Same goes for all those sorting things, binary search, all these hash maps, hash table, heap data structures. If you can find that in the standard libraries, you can always use those stuff.
Does the Python could be applicable for that, or is there any variations for it?
I'm sorry, I didn't get that.
Like in that CS academic runtime environment, what would be the Python version? The latest version?
They both provide Python 3 and Python 2. I'm not exactly sure about the subversion, that means whether it's Python 3.7 or Python 3.8. Probably they will provide you with latest version. Anyway, these latest version do not actually provide you with some more sophisticated algorithms. They are improvements to the language most of the times. So in most of the cases, the latest versions will be available in the runtime. They both provide Python 3 and Python 2, and also a runtime called PyPy kind of a thing. So you can also check that also.
Yeah, thank you.
So we have a question. I tried to solve first two cases when it is okay, then I put submit, but it showed me the other cases are failed. Not sure what you are referring to. I think you are referring to something like for the example inputs they have given, you are getting the answer correct, but you have submitted all the other things shows as the wrong answer. Is that the thing you're asking in the chat? Okay, that means like you got the example test cases correct, and if you got the all others wrong, that means probably you have the wrong approach. That means they sometimes they tend to give this kind of a tricky sample inputs also, where any wrong algorithms will also give a correct answer by mistake. So if you are only getting correct answers for the sample input, that means your approach is probably wrong. You should try another way to tackle the problem. I don't think we can use NumPy or SciPy. Sunera, can we use those stuff?
If I remember correctly, we can't, I think. And
they are third-party libraries. So.
I'm exactly sure, but if I remember correctly, we can't use any third-party library. Like only the standard library is available.
And also, I think we cannot use any multi-threading, right?
Yeah, those kind of parallel programming things.
Yeah, parallel programming.
Like they run the code in one core machine, so it doesn't matter.
Maybe it will degrade the performance if you parallel. Can only use those standard library things. The third-party libraries are not allowed. Not allowed, that means they don't have those libraries in their runtime, so they will probably give an error.
not sure about actually NumPy, but most of the cases they are not available there. But and even if they are available, like most of the cases, like we don't like they are not much used as well in most of the days.
Question there, is there any restriction on the number of tries for a question? No, the penalty for each try. So I think there are no restriction for the number of tries you can do. You can try any number you want. Talking about the penalty, like in the CS Academy, there's a thing called penalty. That means if two teams have the same score, if they have the same score, that means for the sum of the scores to all the problems is the same value, then they will consider a thing called penalty. That means the person who, the team who answered earlier will get a lower penalty. The person who answered after that team get a higher penalty. That means if you have only one solution and there's no use of submitting that again and again, that only adds up to your penalty. That I'm not exactly sure how that's calculated. Sometimes I think it's given in the official rules kind of thing. So if you do not have any improvement in algorithm, I recommend not to submit. If you are certainly sure that you will get some more, certainly sure, or at least remotely sure that you will get some improvement, you should submit. I'm saying that like you are confident that this is the same approach as the previous one, then there's no point of submitting. There's only adding to the penalty. So this penalty comes into play when only when the marks are similar. So if you get the higher mark, that penalty does not matter. Penalty is kind of a tiebreaker thing when comparing two teams with the same score.
Yeah, but actually to add to that, don't be afraid to try again as well, because like if it is not the same answer, like the tiebreaker thing does not affect most of the cases. Like so if you have a different solution, always try it. Like if you like don't do anything, your like score will actually go down because others are completing solutions. Like actually in IEEE most of the cases what happens is like when you are looking at your points, they go down actually most of the case because others are doing their solutions and the points for those questions you have done go down. So always try to submit if you have different answer. But as Budvin says, like if it is the same answer, there is no point in submitting it again and again. It only go like figures your marks.
Okay, with the interest of time, we'll close the Q&A. I really appreciate both our speakers for what you have shared with us, even in your busy schedule. Thank you, Mr. Budvin and Mr. Sunera. This sums up an event filled with discussion, which will be really useful for the participants of the IEEE Xtreme competition. And please be kind enough to fill the feedback form. The link is in the chat as well. Now I would like to invite the chairman of our IEEE Student Branch, Mr. Dilendra, to deliver the vote of thanks.
Thank you, Jenny. I believe I'm visible as well as audible. So first, I would like to present our speakers with tokens of appreciations. So first, I invite Mr. Budvin to kindly accept our virtual token of appreciation.
Thank you, and thank you for inviting us for the session also.
Thank you once again. And also I invite Mr. Sunera Avinash to accept our token of appreciation for him as well.
Thank you. Thank you. And thank you for inviting us for this.
Thank you. It was a pleasure. First, I thank Team Codebreakers for accepting our invitation with such a short notice. And I'm especially grateful to Mr. Deepana Ishtavira, even if he's not with us as a speaker today, for introducing the other teammates and coordinating them to organize this session. I'm also thankful to Mr. Budvin Edippuliarachchi and Mr. Sunera Avinash for sharing their invaluable knowledge and experience with us and preparing our participants for the upcoming Xtreme competition. I also thank our counselor, Dr. Siamalan, for all the support and guidance he gives in everything we do. I appreciate our senior treasurer, Dr. Ramanan, for his never-failing advices that lead us in the right path. I also thank the members of the academic staff from the University of Jaffna who are present here for attending the session. I can't forget to mention the organizing committee of the IEEE Xtreme from our university for all the hard work they put in. So I'm very thankful to you and the other members of the executive committee of the branch for their support. Finally, I thank everyone that participated today. Thank you. Over to you, Jenny.
Thank you, Mr. Dilendra. Once again, I am reminding to fill the feedback form. Okay, now it's time for a group photo. So everyone please switch on the camera and use the virtual background as well. Dilisha will take the group photo. Dilisha, are you ready?
The background is uploaded.
Sorry, Dilisha, we can't hear you. So just in case if anyone doesn't have the virtual background, you can find it in the chat.
I'm audible now?
Yes, yes, yeah.
Yes, yes.
Everyone please switch on the camera and use the virtual background.
Dilisha, we can take the photo when you're ready. So I think I'll take the photo, then so on the count of 3, everyone can smile. So 1, 2, 3, smile. Yes.
Thank you, Dilendra.
Thank you.
I hope you all have gained more information about data structures and algorithms. Thank you for registering and being a part of this session.